Okay, so I'll do this one problem, then we'll move into the next chapter. Only because I was interested in this. Um, but not because of the power lines. It says the three power lines. Okay, am I not seeing? I see two power lines. Okay, they're being held right here. Okay, never mind. Exerted force by the pin connected at B and C and D, which in turn are pin connected to the poles AH, and EG, determine the force in the guide cable AI. Since they're all 800 pounds, and since it's symmetric, I think it's going to be the same as whatever shows up over there. Um, so I guess, let's see, there's no real way for me to section this thing without finding out some information. Um, let's see. He wants to find that, but he does not tell me anything else. Any other thing to section or anything else. So the question is which one do I section? If I section this, then I don't know this one, I don't know that one, and I don't know that one. Since really, it's too many unknowns, I think. However, I could work off of the fact that it's symmetric and section it maybe like this. B, C, and D. Any ideas? Or would you want to um, do it like this? That would be kind of cheating because I think he wants me to section it. I was thinking I could treat it, find the forces here, this one, set that one equal to that one, and this one equal to that one. And I'm going to do that because I don't know that I want to work that hard at it. Okay, so if I did that, how would I do that? First, I would tell you that, oops, this thing's got to be pulling that way. Since it's a pin joint right down here, I'm going to assume that. And then I'm going to assume this. Since it's symmetric, I'm going to call this T. I have no other thing to call it. I mean, I know in the book he'll say F, G, E, but that's too many letters for me. So I'm just going to do that. What do you think? So I know since he luckily gave me 800, 800, 800. It's 40 foot, 40 foot. It's 20 and 20, 20 down, 125. All of that is symmetric. So as a result, everything, the tensions on both lines are going to be the same, compressions on both lines. So now what would you do? Any ideas? Okay, I know this is 30 foot over and 125. This is 50 foot over and 125. So I can get my angles. They look pretty close to the same. What would you say? Let's see. All you got to do is just start. If you want to do it, you could just sum moments about everywhere. I could sum moments about A. I could sum moments about B. I could sum moments about C, E. Which one of those would you think would be the easiest? If I did it about B, what would I have to contend with? Let's compare B to A. Which one would you rather do? Sum of the moments about B or sum of the moments about A? And then what do you think? Okay, they're all equal to 0. If you sum the moments about C, what would you see? So if you took C, of course, this doesn't produce a moment. The moment produced by this is offset by that. Moment produced by that is offset geometrically by that. And the moment produced by this load is offset by that load. So you could do a lot of work. What would you get out of that? More than likely, you'd get that equals to that, and this equals to that. There's not much you can get out of C. If I went about A, let's just start with A. First of all, there's nothing coming out of this, nothing coming out of that. So let's go ahead and just do A since it's the first in the list anyway, and we'll see what comes out of it. It's going to be easy to a certain point. Do it that way. So obviously, I should have done it the other way. So 800 pounds times, I got 20 foot over to this load. I got 60 foot over to that load. And then I got 100 foot over to that load, right? So I could do, okay, I'll break them into their parts. 800, is that right? 60 minus 800. Okay, 40 and 40 is 80, and then 20 is 100. So I get all that. Now let me erase all this chicken scratch right here. Only other two loads I get on this thing are this one and that one. Now, I'm gonna revert back to something. And this is just me. And so if I take the coordinate system, it sits like that. I've matched the assumption there. So I'm going to do something really interesting. I can draw a vector from here to here, call it R, or call it R1. Draw a vector from here to here, call it R2. R1 cross, and this I'll call it a vector C. So this is the vector right down here, the magnitude in its direction. How are these related? Any idea? Is there any relation between, so if I drew a vector across to here, to that point, and crossed it with this one, with this vector, so take this vector, move it up to here. Any idea how those relate? If you want to, we can try it. We can check it. Any gut feeling at all? Besides, you just ate maybe the wrong meal. I'm going to check, make sure my audio's on. Okay. No gut feeling. None whatsoever. So let's draw these two vectors. I don't know that I want to necessarily work this hard. So, okay. So maybe, would you believe if I told you they were equal? And if they were, why would they be equal? So if I put that vector there instead of there, why would they be equal? Remember that concept of transmissibility? So that I can move a load along the line of its action. It really doesn't matter where it is. It's still going to produce the same moment. So if that's the case, then I can just do the simplest one. And the simplest one would be plus I, j, and k. But if I'm making these vectors, these all have to have k's. And then my r vector, r would be, okay, 40, 80, 120. And then I don't care, or 0 and 0. And now my c vector, how would you find c? Okay, it would have a slope. It would rise 125 over this. So if I took a triangle that were exactly like that, this would be 125. That'd be 30. C would be 30 over square root of 30 squared plus 125 squared. I plus 125, 30 squared plus 125 squared. So what I'm doing with this is I'm getting a base vector that goes in that direction. So that's your base vector. And then I'm going to multiply it times, like, I'll make a funny looking C like that. And then I'm going to rely on MATLAB. Okay. Okay, so if I rely on MATLAB, I'll draw a vector. I'll tell you what I'll do. Here's what MS, capital C. I may come back and do another one, but I'll say a base vector UC is equal to, or here, I'll just call it RC. It's equal to 30, 30, 125, and then nothing. So those two numbers are 0.2334 plus 9724J. And I could put this in there. And then what I could do is move the C outside of this. So I could put in the 0.23, the 0.97, and the 0, put the big capital C out there. And so that actually is the moment produced by the C. Does that all make sense? Somewhat. I shortchanged it there and there. I didn't put all the digits. And I may rely on MATLAB some here. So if I drew R1, 120, 0, and 0, then did R1, R1 with C times U. C, was it, did I call it UC? Yeah. So I get a value right here, which instead of me, I tell you what, instead of me trying to figure that out, oh, I'm going to have to, I'm not going to be able to do it that way. I'm going to have to pull the value out of there and divide by 661. Okay, so this number right here becomes C times 1, 1668. 168 or 65? 68. And it's associated with the K component, which is just like what these are associated with. First of all, does that make sense what I just did? It's kind of a strange way to do it, but I reverted back all the way back to the original definition of the moment, just because I didn't want to have to think too much, and I wanted it to just work its way out. So if I'm trying to take a moment about A, I just draw a vector to the point of the application of the load. I know from transmissibility, I can move this load anywhere along its line. So I'll put it up here right at the top. Likewise, I'm going to do the T the same way. And so what I'll do now is I'll take these symbols out of here. And for that matter, I'll just try to take all this. Let's see if I do a shift and hit that. Now it's going to move that top of that T. So if I want to, I can do this again with the T. So if I drew a vector, this problem is going to take too long the way I'm working it. If I took a vector, went in this direction, I take the unit vector, okay, call it unit T, multiply it times a variable T, I, J, K, do the same thing, cross it, 120, 0, 0. What I need to do is I need to find the unit vector T, which is nothing more than, okay, so it's pointing down and to the right. So it's pointing, goes in 50 to the X over 50 squared plus 125 squared, I minus 125 over that same value squared. So what I'm going to do is use MATLAB to find that one. So the R in the T direction equal to the right, it's 50. And it goes down 125. And I'll put the Z on here so I can cross it. And then I'll find the unit in the t direction is equal to the r in the t direction divided by the length of the r in the t direction. And I get this, 0.37 minus 0.93 and a 0. And so this thing will end up being, and I'll cross it out, some variable t Okay, so I need to do SYMST as well. And what I'll do, because I may need this later on, I don't know. So if I want to cross it, I don't even need to, here, I'll do this. This time, I'm going to take out the, and do the cross with this stuck out there, and I get this being minus, okay, minus 1.4, and I think 2 here. So I end up with an equation which is, okay, 800 times 20, 60, okay, so 6, 7 is 180, 80 times 180. 800 times 180 becomes a fairly large number, 14400 minus I shouldn't have picked this problem, but it's too late now. Or here, plus 116.68. The compression in that line minus 111.42 tension, and that's equal to 0. So I get one equation and two unknowns. So now I've got to find another spot to take the moment out. Some spot that I can do it that'll be the least work for me. Any suggestions? I mean, I can pick any spot I want. More than likely, you know, the numbers go from A, B, C, D, E, F, G, H, and I. So I can pick anything, any location from A to I in some of the moments. I got to be careful. If I pick, okay, I already picked A, didn't I? If I pick E, I don't get any new equation. So technically, I can pick A, B, and we talked about C is not going to do anything. So A, B, H, and I. What do you think? What do you want to do? I'm trying to find the one with the least work. If I pick one of these, okay, I've already picked this one, which means I can't necessarily pick this one. If I pick B, I'm going to have a moment produced by this, 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 and this. If I pick H, I'm going to have a moment produced by this, this, and this one, that one, and that one. If I pick I, I'm going to have the same situation, this, this, and this, and then these three. So I think it's either it's I or H, for that matter. If it's I, it's going to be the same thing as if it's F. Now he might be doing it different, but I'm finding the things along the bottom. So let's try, I don't know. I'm trying to see which one would have, you know, the I might have the least complexity because it's the furthest to the left. I don't have to find the distance backwards. In other words, if I use H, I got to go back 30 and then back 10 to get to this 800-pound load. So I don't have to do that. So I'm just going to do that one. So if I sum the moments about I, and I'll go ahead and do this in case I want to break down and do the old style. Then I get 0 is equal to, I start from left to right, identify this load, this one. Well, here, I'll do first the 800 pounds up there. So I'll do the same thing I did before. Okay, those are going the opposite way, minus 800 pounds. So the distance from I to that first one is 50 and then 20. So I think that's 70. And I'm going to go ahead and be lazy and say, I'll go to the second one, which will be 70 plus 30, which is 40, which is 110. And then the moment to this one is, it's 110 from here to that load. It's another 40 to there. So those are the moments produced by all those loads. Now I got to start working out the C's and the T for that matter. So before I do that, let me just turn this into a number. And then I'll put that in there. Let's see, 80 or 800 times 70 plus 110. 264. So this is all 264. So that way I'll have this number. So all of this, the magnitude is 264 times that. Now I'll just take my moment arm and run it straight out to here. Now I'm going to be lazy. What I'm going to do is this. This does produce a moment. This force does produce a moment here, but only the Y component, only the Y component, and only the Y component. So what I'm going to do is go get the Y component here, the Y component here, and then the Y component there. I already kind of have that. And actually, that's kind of what happened already. If you look in here, okay, you're looking at K, you have this number times that, minus this number, which was that to 0. So only these two participated. So if I can go in and find that the Y value, I can use just straight that. Well, I sort of have that when you talk about, let's see, UT and then UC. What you see, okay, so for the tension, this was the Y value. It was 0.9285 times the tension was going down, 9724 going up. So I'm going to come back, okay, 9724, if you can help me remember that. I'll even change, okay, so here. This is the value going up. This is the value going down. The one going up was 9724. So this is 9724 times the compressive load there. 9724 times C. This one was some other value. 9285. 9285 T. Now the thing is it's negative because it's pointing down. So now I have everything I need. I can do. Look at the moment arm here. It's 50 and 30 or 80. And it is, did I put, yeah. It is producing a positive 80 distance times 9724 times the C load plus, guess what? Now it's 80, then another 30, then another 30. What is that? 80 and 60. 60 and 80. And that 140. So 140, 9724 C. Go ahead and do one more load. This time it's this component of the load producing a moment in that direction minus, okay, but it's 140 plus 80. Okay, 30 and then another 50, so that's 80. So what is that? 220. So it's 220 to the all the way over to that T, 0.9285 T. And so now I should have two equations and two unknowns. I'm getting kind of tired of this, and I wish I had done it a different way, but it's too late now. So let's see. I'll know better than to do this again. 80 times this plus 140 times same thing. Yeah. $213. So all of this, 213.93. Okay, so all of this, 213.93, the C, and then 220. It's not time to go already, is it? Oh, gosh. This is ridiculous. Well, if you have somewhere to go, you can go ahead. I'm going to keep working. 204.27 T. So I end up with an equation that, okay. End up with this equation. And I end up with the other equation. I could have done this simpler. I picked two moments. I could have picked some of the forces in the X or the Y. But I've gone here and it's too late. So I got, if I solve these two equations together, I should get the answer. Hopefully I get the right answer. Okay, 116.68. Okay, minus 111.42. And make this the C and this the T. So grabbing that from this side, the C comes first, 213.93 minus 204.27. And the right-hand side should be 14400. Oh, wait, too many zeros. Unless I copied that down wrong. And should be a minus. The other one was minus 264000. Now I'm going to go try to do this in a matrix form. Okay, K is equal to 6.68 minus 111.42, 13.93, that's 204.2, and I can't read my own writing, but I think it's a 7. And then I'll inverse that times the matrix, which has minus 144. And then on the bottom, it says 264. Then I get, oh gosh, that can't be right. Okay, what do I got? I don't know. How about 14 e to the 6? So there you go. I don't believe it. First of all, as I look at this, if you had to look at this and tell me, what do you think how do you think the C and the T would be related? What is the X component of the C related to the X component of T? Wouldn't they have to be equal? If you sum the forces in the X direction, the 800 pounds don't give you anything in the X direction, which means that, okay, so I've got to make sure I do this in the right way. Well, I guess it's better to put it up here. This and this, I've got those in the same direction. However, this and this one, got to go the other direction. So this one and this one add up to that one and that one. I know that sounds this and that, but and since each one's equals, they offset each other. Actually, that didn't get you anywhere. That just got you absolutely nowhere. Sum of the forces in the Y tells you whatever the load is, C has to be what? 8. What is 3 times 8? What's that? 2 times 8 says 24. Is that 2,400 pounds difference? I could try to subtract these two numbers, but geez, I don't know that. Here, let's do this. A1 minus A2. Already there's something wrong because they're not the same. They're not 2,400 difference is what they're supposed to be. So somewhere I've messed up in the calculation and I've wasted a whole hour getting there. Didn't you just enjoy that? Now the question is where do I go to fix it? First of all, it's 2 minutes left. And if no one shows up in dynamics, I'm going to sit here for another hour and fix it. So if you see a recording pop back up on statics, I'm going to just be sitting here. Maybe those guys won't come and I can just keep working this problem. If I was working it and editing it, I could take this hour and probably trim it down to 20 minutes. But it is what it is, and I've left you hanging. And it's like watching a bad movie, isn't it? And I didn't even do it the way they wanted me to do it. They wanted me to section it. I didn't even do that. So I worked extra hard for no reason. Can you believe that? Actually, if I look at ways of sectioning it, I could have sectioned it here. Go get the picture. Oh, I know. I can just take the picture. I could have sectioned it and made my life so easy. Here's what I could have done. I could have just come in. Oh, I don't have the snippet. So let's see. If I had a free-form snip, I could have just come down here, gone ahead and, well, wonder if I could do this. Wonder what this would do. Yeah, that's okay. Actually, I think it can erase it. Right. Here, I'll make it white. That way I can erase that little part. Okay, section it off of that. This one, those other two. So B, A. Oh gosh, I could have made this problem really easy. Oops. Well, shall we go and I can just do this in the next hour. Uh-oh, somebody's coming to class. You can't be coming this early. Oh, he's looking for me? Well, I'm in here. Oh, well, he has to come in here. Y'all go get him and tell him to come in here. I'll sign some. No, you don't want to tell him? So I'll go ahead and fix this. After I did this, I can't believe I should have just sectioned that thing. Sorry. But you know what? I think I'm going to do it both ways now. That's annoying. I did something wrong along the way. Do what? It is. But you know what? Well, yeah. See, my friend, he and I, we roomed together when we were in college. I'd go to his house and he'd be watching these awful movies. And I would say, why are you doing that? Well, it's got to get better. So we'd sit there for hours. Everybody else, we were going to Pizza Inn and eating all you could eat. So everybody'd get up and leave. And I'd be sitting there and I'd say, John, why are we still here? Oh, it's got to get better. And I said, well, it's the same actors. It's the same director. It's the same everything.
But did you remember how I talked to you at the parking lot about fluids?